Okay, thanks everybody for coming. My name is Brett Fanshaw. We can make this a little bit casual this evening, and excited to talk to you about the solar co-op. There's folks that are here for different reasons. They're interested in solar, they've been through the co-op before, they're helping us volunteer, get the word out, so all kinds of reasons for being here. And Peter is recording, and so hopefully we can get this out to some more folks that way as well. We've got some more informational meetings coming up in March that folks can attend. So I'm going to talk a little bit about our organization and the origins of Solar United Neighbors, talk about solar technology and some related technology like battery storage and electric vehicles, and then talk about the co-ops and the co-op process, and finish off with economics. Was always my favorite topic in school, not really. But they're important, and they certainly matter a lot when you're thinking about going solar. So a little bit about Solar United Neighbors. We're a 501c3 nonprofit organization. We are working to build a new energy system that puts rooftop solar and people at the center. We think that sort of decentralizing our energy choices not only means using power more efficiently and in a more clean way, but also gives people sort of their power back when they're making their energy decisions. We are trying to build community around these technologies and bring people together who care about solar, care about all of these other kind of new things that are going on, and bring people together to learn from each other, to ask questions, and to leverage their purchasing power in the marketplace for more people to be able to obtain it. We also do advocacy work, so we're busy at the Corporation Commission and at Salt River Project, working on policies that impact folks that are going solar or using electric vehicles. We got started in 2007 at the neighborhood level in Washington, D.C. We basically our now executive director's kid is Walter here on the left. He's in the green shirt. And he came home one day and had seen the movie An Inconvenient Truth, and was really jazzed up about wanting to do something about climate change, and was telling his mom that they had to go solar and they had to sort of do their part. She started to look into it and had a lot of questions and was getting a lot of different answers from the solar companies in her area at the time. And so she was thinking, how is it going to go on my roof? What's the kind of equipment that's involved? How does it work on my utility meter? What's it going to look like when it's done? How do I deal with my local government? Are there permitting issues? How much does it cost? Can I get a tax break? So it's kind of like, there's a lot of things to think about when you're going solar. And so she said to Walter and his friend Diego that they needed to go out and talk to other neighbors and figure out who else wants to go solar and do it. Let's do it together because we can share information and maybe we can get a better price. And so then the neighbors started kind of sharing amongst each other and building the group up, and they ended up having 45 houses go solar in DC in that first co-op. And so then neighborhoods next door started calling and saying, hey, can we do a co-op here? And over time, they've now built the organization out into 12 states and the District of Columbia. So Arizona is as far west as we go at this point, and the program was launched last year. So we've done one co-op so far in the East Valley, and Phoenix co-op is our second co-op. And then a little bit about just what we've done so far in the last few years. So we've completed just over 240 co-ops across the country. We've helped more than 4,600 homes go solar. That's facilitated over $94 million in purchases for solar. So the impact of this does have, has a big impact on the market. Over 37 megawatts of solar installed, and 1.1 billion pounds of CO2 offset over the lifetime of this system. So I think that's pretty cool. And the East Valley Co-op was 40 houses, 20 of them are going solar, and it's about $250,000 worth of solar purchases for all those homes. So here's what I'm going to talk about next. So solar technology is just sort of the basics. So this is what we're talking about here. Solar photovoltaics, or solar PV, is the basic terminology. This is what you see on rooftops pretty much everywhere across Arizona. So some folks early on had also gotten solar hot water systems, and the difference is that solar hot water basically uses the sun to heat water, and solar photovoltaics uses the sun and turns it into electricity. And so most people now, because the PV technology has become very efficient and has become a lot cheaper, folks are really going towards that versus the hot water, because you can power more of your home's energy needs with photovoltaics. And this is the basic diagram of how it works. So you put panels on your home, and it takes the sunlight, turns into electricity. That electricity that's coming from your solar panels is called direct current, or DC, and your home appliances take alternating current, or AC. And so you need something called an inverter, which basically turns the energy from DC to AC. From there, it plugs into your electrical panel in your house, and if the sun is shining, then your appliances will be drawing from the solar that's coming straight from your electrical panel. If you're not home during the day and your panels are producing more power than you need, it'll go back through your meter, which is number 4 there, and back onto the grid, where some neighbor nearby is going to buy the power from you or buy the power from the utility. You get the credit from the power that's extra that's been produced. Any questions about how that works? Great. So a couple terms we're going to use here are kilowatts and kilowatt hours. So kilowatts is how the systems are sized. It's a capacity measurement. And then kilowatt hours is how much electricity is being produced or generated. It's also how much you're consuming. So when you're buying solar, you're going to buy, say, a 5 kilowatt size system. That system is going to produce a certain number of kilowatt hours over the course of the year, depending on where it's positioned on your house, and then you're going to consume a certain amount, depending on your lifestyle. Most people are going to install between 2 and 12 kilowatt systems. I would say it's a little bit more in between that, maybe somewhere like 3 to 6 or 8, depending on how big your house is and how big your budget is. Panels are, this diagram is a 3 kilowatt system with using 250 watt panels. Panels today can be 300 watts or 350 watts. The higher wattage panels and more efficient panels are more expensive. And so, but those can be a good option if you don't have as much space on your roof. You want like panels that are going to produce more energy in a smaller amount of space. So there are a lot of different options for that. And most installers will offer you sort of a base panel and then upgrade panels, depending. This is how the panels put together. So the magic part is the solar cells in the middle. That's what does all the hard work of turning sunlight into electricity. And the rest of it is basically to ensure that is going to work and that it's going to last. So panels come with a manufacturer's warranty that usually is 25 years, and basically says in year 25, your solar panel is going to produce the same amount, or 80% of the amount of energy, or 85% of the amount of energy it produced in year 1. So if that's not happening, you can go back to the manufacturer and they will, if you're under warranty, they'll replace the panel that's not functioning correctly. Then when you, just as far as terms go, panel and module are interchangeable, and then solar array is sort of when it's all put together. So there are other system components that are important. So we talked about the inverter earlier. There's two different kinds of inverters. So one is a string inverter and one is microinverters. And the difference there is that a string inverter is it's basically like a box, and then it strings the panels all together. And then with these DC optimizers, you kind of string them all in parallel, because if they're all strung together and one panel goes out or one panel is shaded, it'll affect the whole output of the whole system. But with the optimizers, you're stringing in parallel, and so if one is a little bit shaded or one is having a problem, it's only going to impact that panel's output. Microinverters basically invert the energy at the panel level, so the inverter is installed underneath each panel, and will just invert the power there and then send it straight back. Different installers like string inverters or microinverters and basically build their business on either offering one or the other. Some offer both. Most of the installers that we had for the East Valley Co-op were offering a string inverter with the optimizer system. And then we talk a little bit about racking coming up, but that's basically how these things attach to your house. Of course, you need the wires to put them all together, and then the conduit to run the wires to where it needs to go. Most houses, you can connect it straight to your electrical panel without an upgrade. If you have if you have like an older house, I have a historic house, and so when I go solar, I will probably need to upgrade my electrical system, but a lot of houses these days do not. So how does this stuff go on your roof? You basically use a racking system, and there's a different, there's basically a way to install solar on almost any roof type that you might have, and I'll talk about that in the next slide. But essentially you are going to screw in to your roof and put beams on over those screws and attach the panels that way. These are kind of the different roof types that you might encounter or that someone might have. So the basic one is the asphalt shingle, where you have a flashing that gets tucked underneath the shingle. A similar thing is used for roofs that are clay tile as well, but just underneath the clay tile. But the important part is that the flashing makes it so you're not going to get water damage in your roof. You want to make sure the water is going to run right over where it penetrates the roof. If you have a flat roof, you can ballast the panels down, which is basically just using weights. Or if you have parapet walls, you can use beams that basically screw into the sides of those walls. And then some flat roofs use what's called a pitch pocket, where they'll put it down and then they'll angle the panel up to face the right way and basically maximize the amount of sunlight that you get. Metal seam roofs can basically clamp the panels right on the seams. Some folks in more rural areas might want to do ground-mounted solar. This is useful because you can build a bigger system, you can generate a lot of power. That way you can face it the correct direction. But in Metro Phoenix, most people aren't going to do a ground-mounted system. So what makes a good site for solar? You want to make sure that it's facing south, if possible. So southern exposure is going to be the most exposure during the day. The second best is if your house faces west. And the reason for that is you're going to get solar production when you're coming home from work at times that you're using more energy, and at times where the utility is generally pricing energy at a higher premium, and so you're offsetting that power and you'll make a little bit back. So that's why east is not quite as good, because power generally isn't as expensive in the morning, and north is just really not good at all because you're not going to get as much sunlight. Shade is another consideration, so we all love trees, but you might have to think about whether you want to keep your tree or whether you want to have solar, depending if you have a roof that's shaded all day long in the place where you'd exactly put your panels. And then enough space to mount the panels and not be obstructed. So you don't want to have like 5 different panels in different places on your roof. You really want them all to be together so that they can be strung appropriately. One thing that we do for folks that sign up for the co-op is we will review your roof when you sign up. So we'll take a look at your house and basically qualify you for solar. It's something that the solar companies will do anyway, but it takes it off their plate so they can walk into the meeting knowing that this person is basically good to go. So what happens when the power goes out and if you have solar? Does anyone know the answer to that? Do you still get to use your energy? No is the correct answer. So there's a safety mechanism that shuts down, basically flips your solar off. Hello, welcome. Grab a seat anymore. No worries. So when the power goes out, the solar basically shuts off, and that's if utility workers are working on the lines nearby. They don't want a bunch of power going back into the system. And so if you want energy while there's a power outage, you'll need to install a battery system, and that will allow you to basically draw energy that's been stored in the battery. So just to talk a little bit about energy storage, battery storage, because it's an emerging market, especially in Arizona, and there's definitely pros and cons to considering storage at the same time that you're considering solar. And a lot of those installers will also do battery storage, and we get group pricing on batteries through this process too. But reasons you might want storage is if you just do not have reliable service and you have frequent outages, if you have a critical load at home like medical equipment that just basically you have to have power for that machine at all times, for emergency or disaster preparedness if you're living kind of off grid or want that option. This is increasingly why more people are installing batteries, is to offset your peak energy usage. And I have a slide that talks about this later on, but nowadays with pricing from SRP and APS, there are times where if you powered your battery earlier in the day with solar, you can draw from it later in the day when power is more expensive and save money there. And then there are some utility rebate programs out there. SRP is offering up to $3,600 right now towards a battery system, which is probably about a third of the cost of a battery. A couple different types of batteries that we'll talk about. So one is the old school lead acid batteries. And then the other is the lithium ion batteries. So you've probably heard of like the Tesla Powerwall. That's the one that's really been out there. There's also the LG Chem, which is this battery. And the pros of this are that it's programmable, so it's a smart battery. It'll know the times of day you want it to turn on and off. It lasts longer, it's more efficient. It doesn't take up as much space as like a bunch of the lead acid batteries that you would need. However, they are just more expensive, and there's some environmental issues, with creating those. And then lead acid batteries, cheaper, tried and true equipment, but take up a lot of space and don't last as long. We have a guide if you want to learn more about storage on our website. So electric vehicles, I think this is really an area where folks are thinking a lot more about, should my next car be electric? Transportation is now the largest source of carbon emissions in the United States, and so more utilities especially are thinking about how to encourage electric vehicles as a way to increase their load and their energy demand. And of course, if you're producing solar on your house and throwing it into your electric car, then you're basically driving on the sunshine that you're living under, which is pretty cool. We do ask installers to price out EV chargers as part of the co-op, and so you can get a co-op price on a level 2 EV charger. We're not currently at the place where we are doing co-ops for electric vehicles. We've kind of called around and thought about that, but just with the way the car market works, it's not really something that our model can do right now. But with an EV charger, it's something that a solar company, basically any electrician can install at your home. And especially the level 2 chargers are the ones that are going to give you like the 10 to 30 miles an hour per charge. The basic, you can charge an electric car just by using the wall plug, but you're only going to get like 4 miles an hour from doing that, and so you're going to have to have a lot of time to basically do that. And of course, if you drive a Tesla, there are fast chargers that will charge your car a lot even faster than that. So there's a lot of different brands and options out there, but something to think about as you're thinking about getting solar. Another reason is that if you're getting solar, you might want to think about adding additional kilowatts to the size of your system. So we've estimated essentially how many miles per year, how much more solar you would need. One little catch-22 that I'm finding in this equation is that the utilities will not allow you to size your solar system more than 125% of your annual energy use. And so there's kind of two things you could do. One is you can max out that 125% in order to then have enough to also power a future electric vehicle purchase. Or you could buy the electric car and charge it for a year, and then you can prove to the utility that you actually need all the power that you're proposing to install in your house. So, maybe some decision maker someday will fix that problem. So just a few frequently asked questions about solar, and then before I jump into the co-ops, I'll see if anybody else has questions. But one is on warranties. So I mentioned earlier all the equipment comes with manufacturer warranties that vary depending on the equipment. So most of the panels are warranted for 25 years to produce power. The inverters are usually warranted for about 10 years. EV chargers are warranted for about 3-ish. And then another important thing to think about from when you're getting a bid from any company is the labor warranty. So that varies widely depending on the company that you talk to. And that warranty covers the workmanship that's done on your house as a part of installing solar. So, if you think about it, they're literally punching holes in your roof, and so you want to make sure that is done appropriately, and if there's any issues that you can call them and have them come fix it under your warranty. So something to definitely think about. We always tell folks to call their homeowners insurance company if they're getting solar and let them know that that's something that they're doing. A lot of times your premiums will not go up, and in fact sometimes your premiums will go down. It depends on the company. The reason for why it would go down is it could be considered an improvement on your house and actually something that's protecting your existing roof and your property, because any hail or anything that's coming down on your house is actually just hitting your panels instead of your roof now. And so you should question it if they try to raise your rates. Maintenance, solar is not no maintenance, it's low maintenance, so you want to get like a system check once in a while and make sure everything's going well. I always tell people to install the app or whatever that is offered so you can monitor how much your solar is producing at any given time, and you can kind of identify any problems. But every 3 to 5 years, it's probably a good idea to have have a company or the company that installed your system come and do a maintenance check. It's like your irrigation system on your yard. You want to make sure it's working Systems last typically 20 to 30 years. You know, the panels are warranted 25 years, so it's a long-term investment. And then the HOA issue. So this was brought up before the meeting today, but Arizona has a state law that says that HOAs cannot stop you from installing solar on your property. HOAs are allowed to put up reasonable rules and regulations as it pertains to what it looks like and where it can go and all of that sort of thing. But this has been taken to the state Supreme Court, and basically says that they are not allowed to outright stop you or outright make it too expensive, too prohibitively expensive for you to install solar. We're always interested and able to help if folks are having trouble with their HOAs. I've talked to a couple of folks so far that are having this problem, and so come talk to us if it's becoming an issue and you want some help. And then for a historic district, I live in a historic district. We were just talking with folks in Willow this weekend, and so folks are thinking about this. There are historic guidelines from the city of Phoenix for historic properties. So if you want to maintain your status as a historic property, you need to follow those guidelines, which essentially say, can't be seen from the streets, need to maintain the integrity of the property, different things like that. So I have some guidance from the historic preservation associations that I'm happy to share with folks as they're going through this process. So let me stop there and I'll see if anybody has any questions. And then we'll talk about co-ops and economics. Yeah?
How many companies are usually competing, or do you have choices from?
So we're going to cover that in the next section. That's a good question. We had, the short answer is we had 4 companies bid on our last co-op, and we have we have probably like 20 different companies that get our bids at this point. Yeah. Just in Arizona. Cool. Let's move on to answer any other questions. So, solar co-ops, this is our kind of unique structure that we're pursuing here now in Arizona and have done a lot of across the country. So it's basically a group of neighbors that are going solar together. So I get a lot of, well, aren't we just sharing energy and this is going in one particular place? And that's not what we're doing here. In other states, that those type of arrangements are allowed, where it's called community solar, and you can kind of purchase part of a larger system that folks are sharing. In this particular place, the co-op is really like a buyer's club, and is bringing together folks to leverage their purchasing power for an entire installation on their own house. The group itself chooses the solar company based on the bids that we get back from installers. So Solar United Neighbors does not, we don't have a vote, we don't choose the company, it's voted on by co-op members themselves. And then you get support from us throughout the process, so you can always call and ask us if you have a question about your contract, if you have a question about something the installer said or is doing, and then we have weekly check-ins with the company that's chosen along the way to make sure that, if they're having any issues reaching people, or if anything's coming up on their end, like an HOA issue or something else that we can help with. So some of the benefits of going with the co-op is you can get a good value on your installation. I have a slide in the next section about pricing and how our co-ops can drive down the price of solar, but we also can, procure stronger warranties in some cases, procure different prices on equipment. So, and it's also a chance to connect with other people who are kind of thinking and going through the same process, and becoming kind of more part of the solar movement. So this is on a handout that's in the back, so you can look at this when you go home as well. But essentially, this is the co-op process. So we are kind of in phase yellow at this point, where we're getting the word out about the co-op. We're having folks to sign up and to build the group to a point where we can get it out to RFP phase, and then continue to grow it by having folks in the co-op reach out to their friends and neighbors and ask them to join. Once we have around 30 folks in the co-op, we'll send a request for proposal out, and at that point, installers can bid on the project. We facilitate that whole process, so we sort of collect the bids and put them into a digestible spreadsheet, which then is presented at a selection committee meeting. So any member of the co-op can be a part of the selection committee, and we spend a few hours one night basically sifting through the bids and voting on one company to pick for the group. And then once that company is chosen, they start to call and meet with folks that have signed up for the co-op, starting with the folks that signed up first, and working through the group forward that way. Folks get a visit at their house, an individual proposal based on your energy usage and your budget and your household needs, but it's all based on the co-op pricing that we've negotiated with the company through the bid.
Yeah, Brett, if you have a group of people who have different setups in mind for how they would set up their solar panels, let's say somebody's going to put it on a flat roof, somebody's going to put it on a slanted roof, somebody wants an array, can they work with all those together, or do people have to be doing basically a uniform thing?
No, all of those are fine.
Oh.
Yeah. It's we've got folks that are flat roofs, tile roofs, asphalt shingle roofs in the current co-op, and they're all getting the same pricing. Some in the bids, some of them will have like adders to say, like slate, for example. Slate roofs are actually pretty hard for the installers to do, and so they'll say, okay, for any slate roofs, we're going to add 25 cents per watt to that install because it's just more for us. So there might be particular situations where they'll say it's going to cost us a little more to do your house. Yeah. A couple other things to add. So one is it's totally like free, no obligation to sign up for the co-op and to get this information. And we want people to make an informed decision. So like you can decide to sign a contract or not sign a contract. That's totally up to you. Signing up for the co-op does not like require you to go solar at the end of the day. And then so what's in it for us? We get $600 per signed contract from the installer, which we ask them to build into the group pricing. So that's not like something that we're going to ask you for at the end of the process. It's just something that we go to the installer after somebody signed a contract and is going solar, and they pay us directly. So your discount is built in, and you don't have to pay us for that. And then folks are getting installed, and then we try to get together and throw a party. We haven't figured that out yet for the East Valley Co-op, but Peter, I hope we can figure that out soon. So Peter was in our East Valley Co-op, and he's getting installed on Thursday, so he can answer any questions that folks might have about this process.
At least up to this point.
Yeah. I mean, you haven't put them on.
Like I can share the excitement and the anticipation, and on Friday I can tell you how it's going after the install.
Right, exactly. Okay, so just to recap, who picks the installer? Co-op members pick the installer, not us. And these are different things that we look at when we ask the companies to bid. So basic price per watt, equipment, and the quality of the equipment, the different warranties. We also look at track record. So is this a local company? How many employees do they have? How long have they been around? We ask for 3 references who we call through of customers of theirs in the past, and like ask them, did they keep a clean construction site? Were the sales guys nice to deal with? Did you have any issues? And then we share those experiences with the selection committee through that process if there are any red flags that come up. We check ROC compliance, register our contractors, and make sure that they're registered with the state. So there's some consumer protections that are built into the process that we try to let people know what we know. It's ultimately up to the group to decide, but we try to give as much information as we can. Okay. Econ. Few general considerations. So solar is priced by the watt, not by the panel. You're not buying a number of panels, you're buying a wattage system, and then the cost of all the components of that system is built into your price per watt. So it includes the inverter, it includes the wires and the conduit and the labor, all of it. So you can't just say, hey, like, I only want to buy 10 panels and not 11 or whatever. They're going to price the system that way. So if solar's $3 a watt, which is kind of a conservative average for Arizona, it can be lower than that. And you need a 5 kilowatt system or 5,000 watts, it's going to be around $15,000. Talked about this earlier, but it's long-term investment. These things are going to last 20 to 30 years, so you want to think about your payoff being down the road and not sort of tomorrow. This is a question that comes up a lot, so should I buy or should I lease? You've probably seen those ads out there for like no-cost solar, or someone's at your house saying, we can put solar on your house for no money tomorrow, and all this stuff. There are programs where you can lease the panels for no money down, but you are paying that company every month for the power. And the way the math works out is hopefully your lease payment is still lowers your bill because you get the credits back on your bill, and hopefully that savings makes up for the lease payment that you're paying the company. Typically, it's not going to be the same kind of savings that you would see if you bought the system or financed the system to buy yourself. And I'm told that now there are loans out there where you can get, the loan payment would be similar to what the lease payment would be, but you're going to own the system at the end of the process.
Does that make it simpler when you're selling the house?
Correct. So that's the other consideration is I think folks that lease their solar find it's harder to sell their house down the road because the buyer has to agree to take on the remaining terms of the lease. Most of the lease terms are for 20 years. And so someone that's going to buy your house 10 years from now has to agree to pay this company $50 or $70 a month or whatever it is for the remainder of the time of the lease. So, yeah. I'm helping, my folks are considering buying, my folks are about to retire and they're thinking about buying a house in Sun City, and I'm like helping them look, and there's a bunch of houses that have solar, and then they're like, yeah, you have to agree to pay $70 a month for the solar for the next, 15 years or whatever, and so it's kind of a turn off to some people.
Whereas if you own it, you're just turning it over to them as part of the house.
Yeah, it's just an improvement on the house that exists with the house and the cost of the house. Yeah, exactly.
And the warranties are transferable to the owners through the period of the warranty.
Yeah. Yep. For the labor warranty, that you probably have to read the fine print, but I would assume for most of the manufacturer's warranties that it would be good. I think a lot of the labor warranty is contingent on that you didn't tinker with the system yourself, or try to add a panel, or try to have a different company do something. Most of the time that will avoid the labor warranty. Yeah. Did you have another question, or was that your?
No, Peter read my mind.
Okay, perfect. Yeah. So just equipment and warranties and the experience of the installer are important to think about. Utility rates, really important to think about. So which utility you have will sort of determine how quickly you can get paid back, or under what sort of rate design you're going to have to live under with solar. And I have some slides that kind of wonk out on this in a little bit, and hopefully won't put you totally to sleep, but happy to talk about that further. And then, prices for energy are going up, so going solar essentially locks in your energy costs for the lifetime of the system. APS just filed for another rate increase. I think it was another $184 million, which is about double what they asked for and got 2 years ago, which mostly, interestingly, were upgrades to a coal plant, which they now plan to shut down 7 years early, and so, which is great. But I think there's going to be some discussion at the commission about what they're going to be allowed to get and why. So something to think about. Oh, and then historic preservation, we already talked about that, but if you're in a historic district, think about that.
Do you have to go through the historic, do you help, as the co-op, do you help to go through the historic process? Do you have to bring it up to the historic board prior for approval?
That is a good question. I haven't had to navigate that yet here, but I'm interested in helping. I think the installers will know the process, and then I can share with you what I have from Jim McPherson and the historic preservation guidelines from the city, so you can see what that means. I don't think you have to go through a review board, but I don't know. That's a good question.
Because it seemed to be some kind of issue when I talked, but this has been a while.
Okay, yeah. Happy to talk more after, or sorry, some other time. Yeah. Okay, so I think this slide's pretty cool. Solar has basically come down by about half the cost in the last 10 years or less. When we started tracking our co-op pricing across the Solar United Neighbors network, we found that we're generally 15 or 20% below market for the pricing that we're able to procure, which is pretty cool. So,
and SUN is Solar United Neighbors.
You got it.
Yeah.
Okay. Yeah. You were today years old when you realized that. So we keep the bids confidential for every individual co-op bid because the companies, this is proprietary stuff. They don't want their information out there about what their pricing is. But we can give averages for what, the pricing per watt is compared to the national averages. So folks can save. And then this is the reason why. So the cost of solar has come down, but then the makeup of that cost has also changed. So the components are the yellow part on the bottom, and that cost has really fallen. Labor costs have gone down, but have kind of stayed the same relative. And then soft costs, which include marketing and finding customers, have really become a bigger part of the pie. And so there's a lot of companies out there that are fighting for business, that are paying for all kinds of advertisements or door knockers or whoever. I think the last research I saw was that I think it's like $2,000 to $3,000 per signed contract is what they spend to try to find you. So they're happy to pay us $600 per contract. But this is another reason why the co-op can cut the price, because they can shave off the sort of retail cost that they would have had to spend to find this group of customers otherwise. They also can, most installers will basically, when they sign a contract, they'll then call and order the equipment. And so for them to be able to have a bunch of signed contracts in a group all together, they can call and order the equipment in bulk and get a better price for themselves that way. So that's another way it helps. You may or may not have heard about this, but the biggest driver, biggest incentive that folks have for solar right now is a federal tax credit that for many years has been worth 30% of the cost of the system. that you can write off your federal income taxes. And if you do not have that tax liability, you can actually roll it over the course of 5 years. So if you didn't have, if you bought this system and you didn't have $5,000, almost $6,000 in tax liability, you could roll it over 5 years and use it that way. Unfortunately, this tax credit is decreasing and then going away. So any system that's installed this year will get a 26% federal tax credit. Next year it's 22%, and then in 2022 it's scheduled to zero out. So this is something that's been extended before in Congress. We tried with some other groups to extend it at the end of this last year, but failed as a part of sort of a bigger deal. So we'll see, but this is kind of another market pressure that's, that if you're thinking about going solar seriously, this year or next year would be a good time to do it, to be able to shave a little bit off the cost. Some other incentives to know about. So the Arizona state has a state tax credit that's worth up to $1,000. So that's a really good incentive program. Not every state has something that generous. We have a property tax exemption in Arizona, so if you install solar on your house, unlike let's say a brand new, I don't know what increases your property value, but like a brand new kitchen or something like or some other improvement on your property that might raise your tax assessment. Solar does not raise your tax assessment even if it increases the value of your property for sale. The solar access law is the one we talked about earlier, where HOAs cannot stop you from getting solar. And then some other communities have different local incentives and rebates, like the city of Tempe will rebate you your permitting fees once you're done with the process. So there's different things that cities can do to make their process easier, and so you should look into that. Mostly your solar company will navigate the permitting process for you and the interconnection process. So we can't have a solar presentation without talking about net metering. It is like the base policy by which solar has been built in America, residential solar anyway. It definitely fueled the residential solar market in Arizona for many years. We've now, unfortunately, replaced it with, for the most part, what's called an export rate, and I'll kind of explain the difference there. But the basic idea is that you are using, so when you're generating energy, you're using energy at your house, it's coming straight from your solar, and it's not counted by the energy you need from the utility. I have a slide that kind of explains this, but so when the sun's shining and you're using power in your house, then it's coming from your solar and you don't have to, it's not going to show up on your bill. At night, or if you're drawing more power than your solar is producing, you're going to need to draw from the utility, and that's going to show up as an energy charge on your bill. But let's say you're at work all day and your solar is working hard and sending energy back to the grid. The utility is going to pay you and credit you for all that extra energy that you've been sent back. And so at the end of the month, your bill is basically that net energy that you've needed from the utility, plus the fixed charges. So different utilities have different fixed charges, and then subtract the solar credits. And so that's how you save on your bill. Is you're gonna need less energy overall, and then you're gonna get credits for that extra energy that you sent back. But the export rate is set by the Corporation Commission for APS and TEP. So that part of the calculation where any of that extra energy that's getting sent back, it used to just be that energy was worth whatever energy you would have bought at that moment. Now it's worth a set dollar amount. So this year it's worth 10.5 cents. So if you sign up for solar with APS, you're going to get 10.5 cents for every kilowatt hour that you've exported back to the grid. Depending on what rate plan you're on, certain times of day, you might be buying power that's cheaper than that or more expensive than that, but that's just the base rate.
You said that's APS, SRP too, or not?
SRP is different. We'll go over that a little bit, but they have export rate plans, but then they also have net metering plans. So, and some of them have different charges associated. The export rate, another kind of pressure to go solar sooner than later is that the export rate is declining by 10% per year. So you get the export rate locked in for 10 years when you sign up, but next year that 10-year rate is going to be 10% lower than it is this year. So it's another pressure for folks to sign up for solar sooner. After 10 years, it could fall kind of off a cliff, and you'd only be getting the sort of avoided cost of solar relative to large-scale facilities. So you might, you'd be getting that 10.5 cents back for 10 years for any extra energy, and then 10 years from now, you might get 2 or 3 cents back, unless things change at the Corporation Commission and they stabilize that policy at a higher rate for a longer period of time. So here's what solar costs and what you can expect back. We've included some ranges on here because it really depends on your energy use. The rate plans are complicated and vary quite a bit. But if we're assuming solar is $3 a watt, and through the co-op you can maybe get a cheaper price than that. We've got 4 kilowatt and 8 kilowatt systems, so 4 kilowatts on the smaller side, 8 kilowatts on the bigger. Net cost is around $8,000 to around $16,000 or $17,000 after the incentives. And then electricity savings, again, will vary, but this is kind of what you could expect to come away from based on the APS rates and the modeling that we've done. And I've got some sheets that kind of walk through our math on this a little bit more in depth if you want. APS has 3 different rate plans that you can choose when you're going solar. And they're all a little bit different, but 2 of them are more similar than the other one. They all have a basic service charge, which is about $13 a month. So your bill will never be less than $13 a month. It's actually like it's like 4 cents a day or something. So depending on the month, it's like could be $12, or I think the average is like $12.60. A lot of people are using the Saver Choice plan when they go solar with APS. The energy charges are higher, but that also means that when your solar is offsetting those energy charges, you're making more back because you're not paying as much for that power. And then it comes with a super off-peak rate. So if you have an electric vehicle, it's a good plan to be on because you can charge that electric vehicle overnight at a super low energy cost, around 3 cents per kilowatt hour. There's no demand charge associated with the Saver Choice plan, so that's a benefit. Talk about demand charges in a second. There is a grid access charge, which is another fixed charge on your bill for this plan. So if you have let's just for ease, if you have a 10 kilowatt, I actually did some math here on the bottom. So if you have a 7 kilowatt system, it's basically 93% of 7 is $6.51. And so you have a $6.51 charge on your bill every month, in addition to your $13 a month. And they call that a grid access charge. It's basically your permission to send stuff back and use their lines that they've built. The export rate is the same for all these plans. So the other 2 plans are more similar to each other. They have cheaper energy costs, and these are the ranges for roughly off-peak and roughly on-peak. And then these each have demand charges associated with them. So demand charge with APS is calculated based on the 1 hour that you're drawing the most energy on peak from the utility. And then they will multiply it by these costs. So if you're on the Saver Choice Plus plan and your max on-peak draw was 2 kilowatts during the month, it's going to be 2 times 840, so 1680 would be your charge on your bill for that month. So it does kind of rack up the fixed charges, because then you're, but and for that system, the 93-cent grid access charge is cheaper than paying a demand charge. So, but it depends how much demand that you use. Any questions about that? We could talk about this for a while, but I'm gonna move on.
So,
Yeah.
do you sit down as a co-op member, like, do we sit down and go, because we have APS, and I know that they've had a lot of changes and things like that.
Yeah.
Can you change, like, how much can I get help on figuring, like, what would be the best plan and system? That's, I think, the thing that's holding me up on getting solar.
Yeah.
It's
Yeah.
just figuring this out, because I know with tax credits and things like that going away, what point is there a diminishing return to your investment?
Mm-hmm.
Figuring those things out. It's essentially the big sticking point for me right now.
Yeah, I think it is for a lot of people. So we are doing some of our own modeling to help figure some of that out, and would be happy to kind of talk to you about what your bill looks like and try to plug some of that information into the models that we have. Most of the good solar companies will also be able to do that and basically size your system and basically point you in the direction of which rate plan is going to be most advantageous based on their other customers and their other rates. But you want to make sure that they know what they're talking about. So that's something we can help with, hopefully. Does anyone else have SRP besides Peter? You have SRP too? Okay, cool. So we will cover a little bit of SRP. So SRP, the rate plans are not as good. These are also on the back of that sheet. And we can talk about why, but the savings are going to be less with SRP and take longer. There are 4 different plans with SRP. If you become a solar customer, about 4 or 5 years ago, they changed their whole system from net metering to a new system, which was the E27 plan. And then last year, they added these 3 other plans as options for customers. Based on our research and modeling and some research done by some students at ASU that I've been given, almost none of those, there are different reasons why you might go on some of these plans versus other plans, but almost none of them are better than the E27 plan that was put in place before. So the 2 plans on the left are similar, and the 2 plans on the right are similar. They all come with a $32.44 a month charge that you can't ever get rid of. So your bill will never be less than $32.44 with SRP and solar. The 2 customer generation plans on the left have really low energy charges, and so that's a benefit if you're using energy that you're not going to get all from solar. It's like the cheapest energy rates per kilowatt hour that you can basically get in Arizona and in most of the country right now. It's pretty cheap. Part of that is because you're paying a high fixed rate, so they're getting a lot of their money back just in that big chunk. And then these plans do come with demand charges, so they're getting another chunk from you through the demand charge, which varies widely depending on the time of year and how many kilowatts you're using in a 30-minute window. So APS uses an hour window, SRP uses a 30-minute window. SRP also has a longer peak hour period than APS, so SRP's on peak is 2 to 8 p.m., APS's is 3 to 8 p.m., and then APS is 3 to 8 all year round. SRP has peak hours in the winter in the mornings from 5 to 9 and then 5 to 9 p.m. So they have a kind of a heating peak in the morning that they charge extra for.
And APS is constant, you said?
Right. APS does not have a morning peak period. So it's funny, these two plans on the left offer net metering basically because their energy prices are so cheap. So they're paying you back 4 to 6 cents for everything you send back, depending on the time of day. And they're not losing a ton because the prices are so cheap. These other plans on the right are time of use based plans. So they have much higher energy prices during peak hours, upwards of 20 to 24 cents per kilowatt hour. But they do not have demand charges associated. And then they have export rates. And you'll remember the APS export rate is 10.5 cents-ish. This export rate is 2.8 cents on these plans, so you're really getting a lot less back for any extra solar that you're sending back. So there's not a really good, a lot of people with APS that we're finding are essentially getting smaller size systems because the payback is harder to achieve. And if you get a smaller system, it's going to cost less upfront, and you're going to be able to pay it off. So that the nexus is just a little bit different for APS than it is with, for SRP than it is with APS. Any questions about that? Yeah.
How does the battery storage option factor into this?
Good question. So we talked about demand charges, but essentially, they're this charge that's based on how much power you're using at one period of time during the month, during peak periods. The history is actually they have been mostly used for commercial customers because if you think about it, you have a big factory that's producing lots of widgets, and you have lots of machines. You're going to pay that premium to be able to turn all those machines on at once because the utility has to have enough power and all that for you to draw the energy. So that's, they've essentially taken that and said, well, all residential customers are basically like a big machine factory that's like, turning all of your stuff on at once when you come home. So demand rates for residential customers are a very new phenomenon. Most utilities across the country do not have them for residential customers, but the Arizona utilities have kind of gotten them through their regulatory bodies. But they can be a benefit in that they encourage people to use less power during peak periods of demand. From a sort of a cost standpoint, you have to build less peaker plants to have extra energy. Most of those peaker plants are also dirtier to run because they have to ramp up the gas, mostly gas plants, quickly. So if we're using less power during peak and we're kind of generating more from ourselves, then we might not have to build as many power plants and have as much pollution. So, but battery storage and then demand management systems can basically help you deal with demand charges. So, what most people are doing is, it's kind of two things. So, one is just knowing that you have to use less power and not use all of your major appliances at once during peak hours if you're on a demand plan. And if you feel comfortable doing that, you can probably save some money on installing the load management system. They can cost around a couple $1,000 in addition to your installation. But if you want to have a safety net and you want to be able to basically set your maximum demand that you're going to draw, these are pretty smart devices that are becoming more ubiquitous and used for residential purposes in this context. So you can think about it like cruise control for your electricity demand, and essentially you'll order your circuits to turn off if you're going over. So like if, so you're getting one of these, right? Yeah. So basically, you know, Peter's gonna decide, okay, if I never wanna draw more than, 3 kilowatts from the utility, and if I do draw more, I'm gonna turn off my drying machine and my washing machine and my dishwasher, like in that order. And so you won't be able to use those appliances if you're trying to use them all at once, but you then won't subject yourself to like a $200 charge on your bill that month because you forgot, or someone else is like at your house and they don't understand.
And then you could program it for the on-peak time, so other times it would not.
Exactly, yep, exactly. So
So would that be in the same if you use, like, for the load management system? So if we get a lot of power outages, like regularly, almost monthly, somewhere along the line.
yeah.
And you can manage that to say, don't turn on my air conditioning if I'm just running on batteries, if I'm out of, can you do that? Is that one of the things that a load management system?
So batteries, it's a little bit different if you're running on backup power for batteries.
Right.
You probably won't be able to run your air conditioner
Right,
at that
that's what
point.
I'm saying, you can't usually.
Yeah, so you won't need to tell it not to because the batteries will only be hooked up to certain circuits.
That's what, okay. So
Exactly.
Okay.
Yep, so the batteries can be programmed to prioritize different.
So you can't do
Sure.
that,
Your
you
home.
can't prioritize it in a situation where you're using on backup battery.
Yeah, and it won't be prioritized necessarily, it'll just be, I want to run my refrigerator, I want to run these outlets,
Right.
I want to have this fan work, and you can kind of, so like people in California are going all in on batteries right now because of these planned blackouts, and they want to have power, and so people are actually having to think about, okay, how long can I last with my battery bank, and what draws and what demands do I incur? So like you could put more things on the circuit knowing that, okay, usually my power comes back in 2 hours or 3 hours, and so I can last that long. But if it's going to be a whole day or 2 days, you might want to put less things on because then it'll go. I'm not sure about prioritizing. That's an interesting question. Yeah.
On the size of the battery system, the question is relevant because SRP's battery storage incentive
It's based on the size.
and they allow you, they pay $300 per kilowatt hour DC on the size of your battery. And I'm just trying to understand, what would the normal size of a battery be if we're getting a 6.5 kilowatt system on the roof?
Yeah.
What would a logical battery size be for that kind of system on the roof?
It depends what you want to use it for, I think.
Yeah.
So if you want to use it for backup, you would have to then know how much you want to power. If you want to use it to like shave off your peaks, so this is another way you can use the batteries,
Right.
is to shave off the peak periods there for demand charges or during the time of use plans. And then there are, I don't know the exact answer, like scientifically, kilowatts of size to kilowatt hours of battery. Someone else would be able to answer that for you that works.
Yes, I mean, not even round numbers like you'd be getting a 10 kilowatt hour battery,
I think they're sized like 6 to 10.
6 to 10, okay.
Yeah, or you get like a 6 or you get like a 10.
I see, okay.
Yeah, something like that.
Otherwise, these are all just a foreign language,
Yeah.
the numbers are, so.
Yeah. And more people are starting to crunch the numbers on, okay, if I'm on like a heavy time of use plan where my energy is 24 cents a kilowatt hour between 3 and 8 p.m., can I, use solar to not have to pay that much for the first part, and then once the sun goes down, can I draw from a battery to help me lower the rest of it? And so there's some math where you can figure out like what your payback might be from a battery if you're using it that way, but that's a very new phenomenon. Yeah.
But like in SRP land, we've got the 5 a.m. to 9 a.m. and 5 p.m. to 9 p.m. peak times, and one might have, if one's not home during the day, one might accumulate more in your battery to then limit what you're getting from SRP to keep the place cool in that 5 to 9 p.m. peak time. Is that kind of how it might work?
Yeah.
Okay.
Yeah, you can program it to do that. Yeah.
Okay.
So it's a new frontier, I think. It's interesting.
And it also sounded like, so we're not getting a battery system right off the bat, Trudy. But Icon Power said that could be added later, after, if we wanted.
Yeah.
Or, and now that I'm aware of the SRP incentive, I might consider that if they're willing to pay. But that's why I was curious, what, 300 per kilowatt. How much?
Yeah. I think and just so you know, I think like a 9 or 10 kilowatt hour capacity battery is probably about $10,000.
Mhm.
So but then you would get like, a little more than 3,000 back
Yeah.
for what it is. Yes.
I just wanted to comment, probably also have to take into account if you're going to be using it daily to try to meet your peak needs. The batteries only have so many thousands of cycles, and so paying a huge upfront cost for something that will only last you 10 years because you used it daily instead of emergencies, there's like that cost to value as well.
Mhm.
Yep.
Okay.
Yep. That's for sure.
Oh, that's good to know.
Okay, so we're gonna wrap up. We're getting kicked out at 8, so I need to wrap up. But a couple things, just what's next. So if you're thinking about joining the co-op, we'd really encourage you to sign up. Again, there's no obligation. It helps us in our outreach to installers to have a bigger group. And then you can get the information and be connected to everybody. And the website is right there. It's also on all the materials. We're looking for some volunteers to help continue to get the word out. We had a good time talking to folks at the Willow Home Tour this last weekend. We're going to be in my neighborhood at the Coronado Home Tour in a couple of weeks, and we've got some other. I just today talked to the Changing Hands bookstore, and they're letting us be outside of the bookstore in Phoenix for a few days in March, which will be fun. We're doing some advocacy work, trying to get the Corporation Commission to increase the renewable energy standard for the state and include rooftop solar customers in those goals. This is kind of, we started pushing for this with a bunch of groups back in the fall, and you may have seen that APS just came out with their plan to get to 100% carbon free by mid-century, and I think it's 45% renewables by 2030. So we're going to continue to kind of move in that direction and to make sure that solar customers are also part of that equation, and it's not just all power coming from the utility. We've got a Facebook group that's a place to connect with other folks. So if you want to join that, that's what's up. And that's it. Thank you all for coming. Appreciate it.